Well, my dear students, this is Unit 3 and Session 1. This is the first session of the Unit 3. I am welcoming you all to this first session of the Unit 3. So, in this particular session, we are going to discuss some of the thermodynamic processes. See, very first, what is thermodynamic processes? Before learning the thermodynamic process, in the previous sessions, I did explain what is that thermodynamic equilibrium. If a system is in chemical equilibrium, thermal equilibrium, mechanical equilibrium, all sorts of the equilibrium, if the system is maintained, then totally we are calling that system is a thermodynamic equilibrium. Well, see, if it's so, what is thermodynamic process? See, thermodynamic process is the passage of the thermodynamic system from initial to the final state of the thermodynamic equilibrium. Or else, the thermodynamic process is the process, the changes of the system from one thermodynamic equilibrium state to the another thermodynamic equilibrium state. During the thermodynamic process, the system of the thermodynamic state changes from one state to the another. The state of the system can be changed by changing the properties like temperature, pressure, and volume. Okay, these are the different types of the thermodynamic systems. Okay, now the thermodynamic systems are broadly classified into two. Number one, reversible process. Another one is irreversible process. Well, what is this reversible process? As the name implies, it is a thermodynamic process which can be reversed to make the system to come back to the initial state without any loss of energy. That means what? A system has passed the initial thermodynamic equilibrium state to the final equilibrium state. If it is reversed, it reaches back to its initial state following the same path which was followed by before it is changes its thermal equilibrium, sorry, thermodynamic equilibrium state. Okay, the reversible process will follow the same path. As I told you, when it is reversed, it follows the same path. Then all quasi-static processes are the reversible processes. So what is this quasi-static process? Okay, one thermal equilibrium state to the another thermodynamic equilibrium state of there is a infinitely small interval. Then the series of thermodynamic equilibrium states passed by the system, that process is called the quasi-static process. See, that's why all quasi-static processes are reversible processes. All natural processes are not reversible process. Hence, this process is a ideal process. Well, during this process, the entropy of the system does not change. So, what is this entropy? Entropy is the property of the system which increases with the temperature. As the temperature increases, this entropy is increases. Okay, if we draw the line in the PV diagram to represent the reversible process, the line on the PV diagram is a continuous line. That will be continuous line. The continuous line shows that is a reversible process. Next is irreversible process. Once again, as the name implies, it is a thermodynamic process which can be reversed to make the system come back to its initial state, but out of with some loss of energy. While reversing, what will happen? There will be some loss of the energy from the system. Okay, along with other than this, what will happen? It will not follow the same path which was followed by before, right? All the natural process are not the reversible process, as I told you. During this process, the entropy of the system increases. Entropy of the system increases. Okay, if you want to represent the irreversible process on the PV diagram, okay, the line will be dotted one. Then the next one is flow process. Well, say flow process means what? A thermodynamic system is there. If the boundary of the system allows both energy as well as the mass to enter into the system and leaves the system is called the flow process. This process where both energy and the matter can move between the system and the surroundings. All the thermodynamic process with the open systems are called the flow processes. For example, air compressor, open vessel, etc. Non-flow process, okay, it is for the closed system. What is that? Only energy can enters the system and leaves the system, but mass will not cross the boundary of the system. Okay, this type of the system is called this type of the system and the process is called non-flow process. Okay, with this information in this session, I am concluding this session. Thank you.